Howdy, welcome back. So we'll begin today's lesson with a motivating example, and kind of through this process, we're going to introduce some important terminology. So let's imagine that we have some sort of collection of movie objects where the movie type is defined as a struct with four fields. We'll have a field for title, which will be a standard template library string, a field for director, which will be also be a standard library string, rating, which is going to be an enumeration type, and then release here, which is going to be an unsigned int. We can see over on the right of the UML diagram, the actual class definition we'll be using to kind of build this up. We have the enum class rating, which is going to contain four constants. We're going to have the G rating, the PG rating, PG-13, and then R, and then a movie, as we just previously noted, will have that title, director, rating, and release here data members. We're going to go ahead and create some movies so we have something to interact with as we're going through today's lessons. So movies is going to be a standard template library vector whose objects are going to be of type movie. We'll go ahead and push back three classic movies to our movies collection. First one's going to be Citizen Kane, which was directed by Orson Welles, received the rating of PG, and was released in 1941. Next is going to be an Alfred Hitchcock film, Rear Window. Its rating is also PG, and the year it was released was 1954. Finally, one from, I guess, more recent years, Pulp Fiction by Quentin Tarantino, rating R, with a release year of 1994. So we got our collection of movies. We've defined what a movie object is, what information it stores. Let's go ahead and, I guess, the different attributes of a movie. Let's go ahead and continue on with our example. So let's say that you want to write a function that finds all movie objects matching some criteria for our movies collection. Maybe we want some sort of way to get back all the movies that were released before some year. Maybe every movie within the collection that was directed by a certain individual, or maybe we're just looking for all of the movies with some sort of specific title. I mean, in recent years, there has been remakes of classical movies from yesteryear. So here, let's consider the imperative approach. So writing imperative code is going to force us to tell the computer exactly how we want to go about this process. So we might have a new standard template library vector containing movie objects identified by filtered movies. We then might go ahead and write some sort of for statement and iterate through each movie within our movies collection. We would then have some sort of way to determine whether or not a particular movie fit the criteria for the movies that we're looking for. In this case, I just wrote out if the movie year release year is less than 1990. So if it was before the year 1990, we'll include it in our filter movies collection by pushing back a copy of that movie. Now, this is what we would have done before, and the direction we're going is, well, how can we maybe get away from this imperative style of coding and begin introducing or structuring things in a way that is more declarative in nature? That is, how could we write declarative code that would allow us to tell the computer what we want and let it figure out how to accomplish it? For instance, let's think about, when we introduce databases, I believe we used movie objects then. I can't remember which movies we were interacting with, but we did have that ability to declaratively ask the database engine for all movies fitting some sort of criteria. For instance, select all movies from, or select all movies from our movies table that have a release year less than 1990. Or a director of Quentin Tarantino. If we look at that and compare it against the imperative form, we can see that kind of a very different style of programming would result. If you've ever read Python code, you typically would see a lot of filters, which would allow us to essentially grab items out of a collection that meet some sort of criteria. We might see a map, which would be some sort of operation that we could go ahead and apply to each of the elements within a container. And then there's also the for each. which is very similar to map, except for each is actually going to modify the items in the original collection, whereas map would go ahead and return us a new list with the particular transform applied to each of the elements within the original one. And if you start thinking about how we're, writing code in that instance, it would just have a lot more of a declarative kind of feel to it, where we're asking for different things to be done as we're maybe moving through some sort of um, steps towards a solution. Whereas compare that to the imperative statement, where we'd be defining each of those processes as we go along, and we're doing it in a manner that describes how they're going to be accomplished versus this declarative nature where we're simply asking and receiving. So, what we kind of want to do here is uh, come up with some way where we could ask for, hey, give me only the items and movies that I want from the particular collection. And we're going to want to make this in a general way, similar to how with the select statement in SQL or command, it allows us to specify what attributes on a particular movie object or a combination of attributes that we're looking for. For instance, we could have wrote out an SQL statement, select everything from movies where a particular movie object has a release year of less than some date, and maybe the director was Orson Welles, and we'd get back those movies from the database. So we want something general here as well. And we're going to see that this is going to take us on a adventure, if you will, kind of throughout the next this lesson and the next. So motivating example. Let's say we have this filter movies function. Okay, and what it's going to return is a collection of movies that is going to have or have been found within the original collection of movies that match some sort of criteria. So again, it could be, they're all directed by, say, a particular director. They have a release year of maybe a specific year or range of years. But how can we describe this function or define it rather in a way that would allow us to kind of capture this general ability to filter this original collection and return back from it a vector with all of the objects that that fit the criteria that we've specified. So if we go ahead and look here, we'll start out within the body of this function. Okay, let's go ahead and create that vector. We're going to initialize filter movies as a standard template library vector of movie objects, which is going to contain each object that satisfies what we're looking for. And then we're going to begin iterating through each of our movies. And again, we want to define this function in a way that when we use it, it's going to look declarative in nature, that we could go, hey, filter movies, pass in the original collection, and then pass in something else. And what we're going to get back is a collection of movies that is going to match what we're looking for. So we need to do something here, but we want it to be generic in the sense that we're not having to have a huge number of if statements. We're not passing in something that's telling us which conditional to execute. We want to keep it short and simple as presented here. And to do that, we want to pass in what we'll see here, some way to determine whether or not the movie under evaluation is going to be or should be placed within our filtered movies vector. So at this point, we obviously need to pass something to filter movies that allows the caller to specify which movies should be included in as general a way as possible. Okay. So we want whatever it is that's passed to be handled, whether we're looking for just the movies of a specific year, range of years, and maybe a particular director. We want to specify it down to kind of any level of filtering that we'd like. Similar to how you could do this when crafting a SQL query to the database engine. Remember, with the ampersands or ands, the ands, you could go ahead and say like select from, movies where movie ID equals some number alternatively, maybe where movie release year is less than 1990 and movie release year is greater than 1947 and director is equal to Orson Welles. Who knows? But you had the liberty to go ahead and craft up very specific queries to the database engine, and we're going to want to define filter movies in a general way that allows us to get as specific as we want in this filtering operation. So this is the direction we're going. Let's introduce higher order functions at this point. So a higher order function is a function that operates on or uses another function. So the question becomes, could we somehow pass a function to filter movies to specify which movies should be included in our filtered movies vector? And the answer here is going to be yes. In C++, we do have the ability to pass functions to functions, which means that we have functions which will be able to receive the functions passed to them. Now think about what we could do there then. Maybe we could craft something like this. So at this point, everything's the same, what we described up to this point, except this line here. And maybe I should point out the parameter as well. So at this point, starting from the top down, filter movies has two parameters. It's going to have that collection of movies for which we're going to apply the filter operation on. And the second parameter here is going to be a function that returns bool and who takes as a single parameter a reference to a movie object that by const. So reference to const to some sort of movie object. And we're going to call that function's filter. So after we pass the function to our filter movies function, so filter movies is now a higher order function, we can go ahead and call that function anywhere within the body of filter movies. So this is how things are changing. So we go ahead and we declare filter movies, and then we have that for statement, range-based for loop, which is going to go through each movie in our collection. And if filter movie, so we're passing to whatever function is bound to this parameter, a movie object, and this function will return true or false. And what we're particularly looking at here is if that filter function returns true, we'll go ahead and push that movie back to our filter movies vector. And then at the end of this process, after we visited each movie in our collection, we're going to go ahead and return our filter movies vector. So the question becomes, okay, could filter movies call filter function on each movie object to see whether it meets the criteria to be included in filter movies? And yes, we can, but how could we call maybe this function with another function? And we'll get into that here shortly, but this is again the direction we're going. And we'll see that this standard template library function type, if you will, as we go through this week, we'll see that it's special and it allows us to get around pointers to functions, which the syntax is a little more cryptic than that presented here, but this will also bind to callable objects, so function objects, as well as Lambda functions. Notice we haven't talked about any of those yet. I'm just pointing out that we're using this particular facility because it will make our lives easier as we go forward. So how would the caller implement filter? We'll see here. So many programming languages support so-called first-class functions, meaning that functions can be stored as variables and passed to other functions. What we're going to see here is that in C++, and unlike some other languages, functions aren't objects per se, and what we're actually going to be passing here is going to be a pointer to a function. And if you think about it, this makes sense, right? Like we said a long time ago that our program space, address space, so memory allocated to our program, has what we consider three areas: a static code region, the free store, and the stack. And we said this static code region stored all of the definitions of our functions. And we said that each function, no matter how many times it was invoked, had its definition stored exactly once. So what that means is there's kind of no concept of an instance per se of a particular function invocation, because instead that code is shared across kind of anytime we're calling, say, function filter movies, we're going up to that space in memory where its definition starts and running through it. So how does C++ kind of support this idea of first class functions within the language? Well, it allows us to pass references, or better yet, really pointers to those functions. And then we'll see some additional facilities and ways that we can actually define callable objects. And so they're called function objects, and they'll provide this very interesting way to kind of preserve state. And we'll see how lambda functions are derived from them. But for all intents of our purposes here, we'll go ahead and consider that in C++, we do have first class functions. We can pass them around to other functions, and we can also return them from specific functions too. So many programming languages, as we pointed out, support this in some way or another, or provide some sort of approximation of it. If you've taken 125, I believe Professor Challen introduced that. In Java, we have ways to approximate this, though it's not supported in kind of the native sense. A language like Python, functions are actually objects there, which is kind of interesting to think about. So perhaps in a more stricter sense, Python's functions might be considered a little more first class than C++'s. But I mean, kind of those perspectives aside, let's go ahead and get into an example of this. So on the left, we have a definition of filter movies, which is exactly what you just saw on the previous slide. Now, I wanted to build this up a little bit. We're going to get into far more details than what's kind of presented on this slide. But some of the intentions of this lesson here is to motivate, right? So let's go ahead and define a predicate function. It's going to return true or false. Its name is released before 1990, and it takes a movie object by reference to const. It's defined as if the movie's release year is less than 1990, we return true. Otherwise, we return false. Now, let's go ahead and see our filter movies function in action for the first time. So assume somewhere we're making this call here. We're assigning the return value of filter movies, which is a standard template library vector of movies, to this variable result. And we're calling filter movies with that movies collection that we built up earlier in this video. And we're also passing the function release before 1990. So what's going to happen here? After we get into this definition of filter movies, after we've initialized the filter movies vector, and as we begin stepping through each movie in our movie collection, filter movies is going to call this function, and it's going to provide to that function this argument as the parameter to movie. Okay, so we're actually calling release before 1990 through the name filter within the filter movies function. Now, if that function returns true, so if filter movie returns true, use a different color there. You all know I like my colors. The movie will be included in our filter movies vector. False, it will not be. And we'll do this for each of the movies. We'll pass them to the filter function. If we receive back that it's passed the filter, if you will, it meets the criteria, we go ahead and push that object back. And then at the end, we return filtered movies to the caller. So in this case, results would store, assuming we're using this movies vector here. So before 1990, the vector would then be composed of the movie objects with Citizen Kane and Rear Window. So that's how that's working, and that's the kind of first time we've seen these higher order functions in action in this class, filter movies being that higher order function. And then we've also seen how the language to an extent considers functions as first class in C++, and that we were totally able to go ahead and pass release before 1990 to a function that received it and actually utilized it to go ahead and implement this filtering operation. Now the question becomes, okay, well, this seems really cool, but it also seems like a bit of a pain. You're, telling me that if everything I want to filter, I have to write out a definition for it. I mean, it looks a little, too focused, perhaps, in that it's very specific. Is there a way to make this more general, or somehow maybe, I don't know, somehow not have to define a function? Is there a way to maybe preserve some sort of state within, if we wanted to reuse a function in some sort of manner? And I know this is all probably going, what's he getting at here? And we'll see, but what I'm trying to motivate is we can pass functions that we've created. We'll also see ways to pass callable objects to our filter movies function, as well as lambda functions, which will essentially allow us to kind of define what we're filtering for on the fly without having to set up a brand new function or without having to define a brand new function object. But I mean, just take it kind of in as it's being presented. We've introduced this high order function, filter movies, and if you just begin looking at this, it should become very clear how powerful this is. If we wanted to filter our movies by some other criteria, we would have just passed a different function to it. And we could have defined this function to be as specific, perhaps, as we wanted. We could have not only looked at maybe release before year, we could have defined this predicate function release before to maybe be some sort of range of years. And instead, I mean, we could have even made it more elaborate in the sense that not only were we looking for it to evaluate a range, look for it to evaluate true on a objects within a specific range of years, but also maybe having a specific director or other features. So just dependent on the function that we're passing to filter movies, we're getting some very generic filtering behavior and reuse for this function where we could begin just writing our code in a declarative nature as shown here. So we're just going, hey, filter movies. I want a new vector of movies for all movies in my original collection who meet this criteria. And it just, if you begin thinking about how this changes how the code looks, it's a slight shift from the imperative to more of this kind of declarative way of asking for and receiving and then performing different computations accordingly. So again, just to kind of reiterate, there are many different ways to pass a function. And you'll see why the quotes are there, as I mentioned, as we go forward to another function in C++. And we will see there are different advantages and disadvantages for each of these kind of means of passing functions to functions. So with that, let's go ahead and introduce functional style programming. This will be the last video of today's lesson. And then we'll get into, I believe, function pointers and function objects in the next lesson. And then thereafter, we'll introduce lambda functions in the subsequent lesson to that one. Alrighty, see you in the next video here.